Okay, now this is kind of our last topic, but it has a few subtopics. Is about process capability. Okay, process capability is really is this how my first of all, once I am sure that my process is stable and in control, now I will go a bit further, look at more details to see how good is my control, how good is how good is the process, and how good are the products that I'm producing. So that is kind of the definition of process capability. Now, okay. In general, the statistical techniques that we have so far, okay, like all these measurements that we have done so far, they are okay. They are really good. They will be helping us to develop the process. They are good. Like to detect the variation, the variability we have, and for quantifying the variability, okay, analyzing the variability that we have, and also at the end, once we know how the process is varying, how the variation is happening, then we can take some action and eliminate and reduce the variability. So this is the first thing. Okay, process capability analysis, which is the topic of this slide and the other slide, is also a useful tool that we can see how variable our data are, our measurements are, and how far they are from the specification limit, LSL and USL, the upper specification limit and lower specification limit. If I have, let's say, if my measurement distribution is my product is distributed like this, okay, LSL, or if my product is distributed like this, so this distribution it has more distance from USL and LSL, but this distribution is closer to USL and LSL. And our control limit are usually located somewhere here, UCL and LCL. Okay, so once we have an in-control process that all the data distribution is between LCL and UCL, we are fine, we are okay, we will see that our process is stable in control. Now we can go a little bit further and see how my distribution is far from LCL and USL. So those are the specification limit that is defined by customer. If my data have a distribution like this, is far from the specification limit, it means I have a better product and my customer will be happy. So this product here, this one is better than this one. Okay, this one is more spread than this one, or this one is narrower than this one. So this is my favorite. This is okay, but if I have a choice between these two, for sure I will choose this one, not this one. So that's a kind of introduction of process capability. So for process capability, first of all, when we are doing the capability analysis, we are talking about an in-control process, a process that is already in control. In control means all the measurements are between LCL and UCL, is a stable process, and we use some capability indices to some capability parameters or indices to do the capability analysis, okay, that you will see in the next slides. Okay, process capability is a measure of uniformity or consistency of the output of product or output of the process. How uniform the how uniform is your products. Let's say if you have a this is, let's say, your LSL, this is USL, and this is your mean or X bar. We can show it in two ways, in mu or X bar. So you can have such a distribution. No, let me plot it in a better way. You can have this type of distribution. Okay, is really in the center of the mean. So the peak is really in the center. Or you can have this type of distribution. Okay, that the peak has a distance from the mean. Okay, it's not really the peak has a distance from the mean. So both of these two processes, they are good, they are okay, because all my data, my measurements, my products, they are within LCL and UCL, but the red one is more favorable because it's really uniformly distributed between LCL and UCL. So the distance from UCL and LCL is almost the same, but this one is shifted more closer to USL. Although both of them are good, but this one is better. So the capability analysis, okay, it shows us this kind of information. First of all, I have a good process in control stable, but which one is better? This one that has a better capability, that my products are uniformly distributed between LCL and UCL. Okay, so we are going to talk about some parameters that we can calculate and tell us that I have this type of distribution or this type of distribution. Okay, that means, like, then we call this kind of distribution more capable than this one. Okay, this is what we are going to talk in the next few slides. Okay. Yeah, so what we will do in the process capability analysis, first of all, we measure the variability of the output. We measure the variability, we find the USL, LSL, then the mean standard deviation, and then we compare, let's say, the mean and standard deviation with USL, okay, with respect to LCL and USL. We will see where the peak, where the mean is located, if it's closer to USL or closer to LSL. Okay, we do this kind of analysis. Okay, so now you can see I'm in slide 19, and next slide is 26. Okay, so there are few slides hidden here. I don't know if you can see in this video or not. So you can see from slide 20, 21, 22, 23, and 4 and 6, they are hidden here, that I just leave it for you. You can study them. It's not something new and it's not also important. And as I said, if you have any question, you can ask me. So, but before I continue, you remember that we had 6 sigma rule in unit 1 or 2, I don't remember exactly. So 6 sigma, as I said, is one of the methods that we use to say if my process, my production is good or not. As I said, when we have what does it mean 6 sigma? Means that 6 sigma means that when I have a product, a measurement distribution that has a 6 sigma, that follows the 6 sigma rules, means that 99.73% of the data points will be within minus 3 sigma to plus 3 sigma. What is sigma? Sigma is the standard deviation of population. So this is mean. So when I have this kind of distribution, when 6 sigma rule can be applied, I have my mean, that my I have 99.73% of my data point that will be between mean and 3 sigma and mean and minus 3 sigma. Okay, so this is the definition of Six Sigma rule, if you remember. And okay, Six Sigma is the ideal distribution. Ideally, we want to have a process, in control process, that we have all our data point that will be between -3 and +3 sigma of my mean. Okay, this is what I want. This is kind of my natural, we call it also upper natural tolerance limit and lower natural tolerance limit. So this is the ideal that I want to have, but the real process, they are not necessarily like this. They are my data are not really very well distributed between mean, and I have sometimes narrower curve. I have sometimes wider curve. It's not always necessary in this is not always necessarily 99.73% of my data point between these two limits. Okay, so this is kind of something that you need to keep in your mind. What we will do, this is my ideal. I will compare any process related to this ideal, and then this is my kind of reference point, and I will consider all the process, compare all the process with this ideal case, and then I can say my process is good, bad, is stable, is not stable, is capable, is not, and so on. So this is kind of introduction. Now, okay, those are hidden slides that you have. You can just go through them and you can study them. As I said, it's just for you, for your information. Now, slide 26. I'm gonna continue from this slide. Okay. Process capability indicates or parameters are those parameters that we will calculate now. We will talk about them and we will calculate them. And as I said, they will show us how well an in-control process is within its own specification limit. As you remember, when I plotted in previous slide somewhere here, that we can have a distribution that is very well distributed between LCL, LSL, and USL, or we can have a distribution that is closer to USL, or it can be closer to LSL. So it's shifted to left or right. So this indicates that we are going to calculate now. They will show us how that process, which is a good and in-control process, how this process is operating between our specification limits. So to do that, to show how it's good or bad, we need some quantities, some quantitative way to do it, to express it. Quantitative means we need a parameter to show us like if that parameter is a big number is good, if it's a small number is bad, something like that. So quantitative way, to have a quantitative way, we can define several parameters. Like here we have 4 parameters and I'm going to talk about them now. So first parameter is process capability potential. We show it with CP. Second one is process capability range, CR. CP and CR, they are almost the same. CR is 1 over CP. As simple as that. We will see in the next slide. So there isn't a big difference between them. It's just, like CP shows that, let's say, the process is spread, the data are spread or narrow. CR is just kind of the inverse. Okay, so it's not something like, both of them are, as I said, the same. They have a relation like this, and some quality control teams, they prefer to use CP. Some of them, they prefer to CR. Upper and lower specification capability ratio is another quantitative parameter that we will calculate. And finally, process capability ratio, CPK, that we take into consideration the centering. Okay, so you will also see what does it mean. That means that we will consider like if my data are well distributed in the center or far from the center.